Hello everyone, welcome back to the channel, and we are continuing our playlist where we are learning high level systems design in a simplified manner. In episode 2, we introduced a 6-step framework to approach any system design challenge situation, right? So let us quickly recap. The first step in our 6-step framework was we clarify the requirements, what we want to design, and we ask questions around that. Then we move to API design, where we take a API first approach and we try to design APIs around the functionalities that we're going to build. Then we go to the data layer and we try to structure our data. Then we estimate the scale of the system that we're trying to design. Then we try to incorporate asynchronous communications components in our system if it's possible and if it makes sense. And then we decide on trade-offs, what can be allowed in our system. So in this video, we are at episode 3 and we will zoom into the first step, that is clarify requirements. Okay. This is a very foundational step in the system design journey, and this step is what separates an average solution from a system that scales in a real world. So let's begin with this step and let's try to understand the problem. Why requirement clarification is very important, and breaking it down, how we'll see how we can break it down. So let's say we are given an open-ended situation where we are asked to design a system like YouTube. Okay. So when we hear this, generally, uh, as we do not have a very structured way to approach this problem, we start thinking in terms of what database we'll use, whether we'll go for caching or not, whether we'll use message queues or not, whether we need microservices architecture or not, or we go for monoliths. All these things might pop up in a very unstructured manner, and this is what deviates and takes us away from what really matters. That what the system exactly does, what is the functionality that we are trying to build, and what the system exactly does. So, in an open-ended question like this, where we are asked to design YouTube, uh, there can be many possibilities. We just take a look at some of them. Let's say we are asked to design YouTube. One possible implementation that we are looking at is a video upload system where we support transcoding. Okay. Another possible system is a real-time video recommendation system or a recommendation engine. Okay. And another thing that might be possible in this scenario is a streaming infrastructure which supports efficient live streaming services. So all these three, and there can be even many more. All these three, they are systems, subsystems in their own, and they have very different architecture and approach to solving the problem, as they are completely different use cases. Okay, so what I've seen in my experience is great engineers and great architects don't jump directly into diagrams. Rather, they clarify the problem first. Okay. So the best challenges and real world architecture discussions always begin with good questions. That is the most important thing, and not buzzwords. Okay. So for building this thought process and for having a mental model that exactly what we need to think when we face such a situation, what I have done is I generally follow a four-layered approach. Okay, a four-layered model of asking the relevant questions that can help us make relevant choices that can be beneficial to our design. Okay, so let me introduce you to this structured model that I personally use, and you can use it too. And it will help you break down any vague design challenge into clarity and with proper steps. So the first step in this four-layered approach is talking about functional requirements. So functional requirements. Okay, so just to recap, we are at the first step of our 6 step framework, and in the first step that mainly tells us to ask the right questions. We are following a four-layered approach to know what questions to ask. Okay, so this will be a little deep dive. So let's see. So we have our architect with us, and he's quite happy as he has been asked to design a system called paste bin, which we discussed in our last episode. Okay, so the architect starts thinking, and he knows our four-layered approach, and he starts thinking. So he tells that, okay, let me ask a few questions. So he starts asking the relevant questions. The first point is functional requirements. When talking about functional requirements, we mainly start by asking what does the system need to do. Okay, what are the core features? That is what is meant by functional requirements. Okay, so our architect, as he knows this point, and he is designing paste bin, he asks few relevant questions to the business owner, okay, or the product person. So he asks that, can the users do CRUD on paste? Basically, can the users create, read, update, delete, or can the user perform all these operations on paste or not? Okay. Then he asks that, are paste public or private or unlisted? What is the access level of the paste? Right. Then he asks that, do we need syntax highlighting on any code if we are supporting, let's say someone pastes a code, a Java function. Do we support syntax highlighting on that code? He also asks that, do we need a user login session, okay, for the one who is pasting? Do we only allow authorized user to paste in our system? Okay. So as you are seeing all these questions that our architect asks, okay, it signifies the most common user actions that are possible on our system, and that is what constitutes of the functional requirements. Okay, that is the layer one in our four-layered frame approach. Next layer is non-functional requirement. Okay, so we are done with layer one. We have built the foundation of the building. Now we uh, move up by one layer, which is non-functional requirement. Okay. So non-functional requirements are those questions that define the shape of the system. Or if you think it in terms of a building, it will define the shape and the capacity and how tall the building will be. Basically, those types of questions. Okay, it will not tell you that what functionality the system will have. It will tell you that will be the scale of the system. Okay, uh, what kind of speed and what kind of reliability and availability are we looking when about this system, are we trying to have in this system, right? So our architect knows this second layer, and following the same, he asks the right questions. So to figure out the scale and speed and reliability and availability and all the non-functional requirements, our architect begins by asking, what is the DAU or daily active users that we are expecting in our system? Okay, so by this we can get an estimate of the uh, daily load that we are expecting on our system, right? And based on that, we can make some relevant choices, which we'll see uh, later in this video. Second, he asks about what is the read write ratio of the system, right? The read write ratio will enable us to understand what kind of database can we use for this. The next step is we 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 try to see what is the data retention policy in the system. Okay, and by data retention policy, the architect tries to understand whether the data has to reside for 1 hour or 1 year, or what is the allowed timeline for that. And the fourth question that the architect asks is, what kind of availability do we need? Do we need 99.99% or how much availability are we looking at this system? So these are called the nines of availability. Okay. So real world system expose five nines or six nines of availability, and this is taken from that. Okay. So when we talk about paste bin, our architect has figured out that there can be 10 million pastes in a day, and each paste can be approximately on an average 1 kb of size. So that corresponds to 10 GB per day, and that corresponds to 300 GB per month. So that would be the data requirements of the system, correct? And using these questions, and our architect has also found out that 80% of the traffic, they mostly will go for the top 1% of the posts. Okay, so that means this hints us that we will need to implement some sort of a caching mechanism, because top 1% paste will be mostly used. So having gotten a fair idea about the non-functional requirement of the system, the architect is quite happy now, and he says that okay, asking the right questions has really helped him. So he moves further. So the next layer in our four-layered approach is deciding on the edge cases and constraints. Okay, so edge cases and constraints. So this layer basically uncovers the hidden, technical or limitations or legal constraints or user-driven behavioral constraints that has to be imposed on the system. Okay, so having known this layer, our architects tries to ask some relevant question that can help him arrive and derive some edge cases and constraints. Okay, so let's see what our architect asks. So the first question that we have here is, what is the max size of a paste that we are looking at? Whether it is 1 MB or whether it is 10 MB or what. Okay, so from this we can deduce that if we allow large pastes, storing and searching them require would require more time, and it would correspond that we would have to implement some chunking mechanism, and we have to go for some asynchronous process for to facilitate this chunking. Okay, so we'll see look at it later. The next question that our architect asks is, should the expired post be auto deleted or not? Okay. Then are we supporting attachments, and what is our action plan when we are abused, or some malware, we are spammed with some malware or something like that. Okay, and are there some legal implications that we're looking at if there are some abusive pastes in our system? So all these hidden limitations or hidden user driven constraints or technical constraints come under this layer. So the architect our architect is smart enough, and he has clarified all these questions, and he has a proper idea of what kind of edge cases and constraints we are looking at in our system. Okay, a industry relevant example on this is, Twitter has strict limits on media size and retention. Okay, so their upload path includes various client side validation and pre-check APIs, correct? So there are pre-checked APIs that Twitter has imposed, and they are S3, pre-signed URLs, pre-signed URLs. So all of these, because uh, this helps us, all these edge cases, drive infra decisions, that what kind of infrastructure should our system have. to accommodate these edge cases and constraints. So that's it about the third layer. So our architect is confident now, and we are moving on to the fourth and the final layer, which is very, very important in our four layered approach, and that is the UX or product flows. Okay, yeah. So we'll have a look at it. So this layer is very, very important, as this layer is the closest to the end user, to whom for whom we are building this system, and this is the layer that most engineers overlook. But in real world architecture, this is what defines user satisfaction, drives technical complexity, and also influences the entire system. Correct. So let's break it down, and we will see that what factors we should handle when we are thinking at this layer. And we'll start with whether asynchronous and synchronous behavior is required in our system. Okay, and whether what kind of feedback mechanism do we have, what kind of error visibility the user will have. Okay, what kind of consistency and immediate effect of the changes is expected in the system. Okay, and factors such as retry, undo, cancellation, what implications have will actions like this have on our system. Okay, whether there are any device specific or network specific behavior. Okay, that is required here. So to answer all these questions, our architect asks below these things. Okay, so in context to our paste fill system, should the paste creation be instant or not? Okay, so this can help us answer the fact that whether synchronous behavior is needed or asynchronous behavior. Then he asks that do we show paste URL right away or not? Do we need to show paste URL right away or not? Correct. Do we support retries and undo? Okay, so these are the relevant questions that our architect comes up with, and having applied all the four layers of the system, our architect is now confident that he can build a correct system. He has his answers, and to he is applying this four layered breakdown model to build Pastely. So let us see that how exactly the answer to these questions help us design Pastely, right? Okay. So this is where we start applying the four layered model. So we are at layer one, right, where we discussed about functional requirements. Okay. So there were few questions that we asked, right? What were the questions? Let us recap. So we asked that can users do CRUD? Are paste public, private, or unlisted? Do we need syntax highlighting? Okay. And is the user login needed? We asked these questions. Now the answer to these questions help us to make these choices in our system. Okay. So for example, can the user create, view, delete pastes? Right? The answer to this was yes. The user has to perform CRUD. So this hints us, or this tells us that okay, we need a REST API layer with basic CRUD routes. That means we have to go with an API first approach. Clear? Now the second question was, what is the expiry of can the pastes expire or not? So the answer that came from the business or the product was that yes, the paste should expire after a certain amount of time. So our architect went ahead and implemented a TTL field, or time to live field, in the database, or we can use TTL indexes as well. So that helped us in making the index choice and the database schema choice for us. Okay. The next question that we asked was whether anonymous or logged in flows are supported. Okay. So based on that, we can implement an optional authorization middleware which will protect our REST API routes based on the authorization status of the client. Correct. And the final question that we asked in our functional requirements layer, our first layer is editable pastes, whether we are allowing editable pastes or not. The answer was yes, we need to support that functionality. So we implemented a unique ID. Sorry. So we implemented a unique ID generation and versioning logic because we want the ability to edit the paste. So using the IDs, we can catch those pastes and we can perform update operations on them. So I hope it is clear to you that how the functional requirement questions that we asked, how each of them mapped to a design choice in our high level system design. Okay. Similarly, we'll look at every layer, how the questions asked help us to deduce a design choice for us. So the second one is non-functional requirements. So in case of non-functional requirements, let us see what questions our architect asked. So our architect asked that what were the daily active users, what is the read-write ratio, what is the data retention policy, and how much availability are we looking at. Correct? So let us look that what these choices mean. So the DAU number for this system is 10 million pastes a day. So 10 million pastes a day is a big number and hence need a high write scalable data store. Correct? A data store which supports high amount of write scale. So that points us towards using a NoSQL database. That's a big design choice that it helps us to make. Okay. Next, we have a read-heavy workload because our read-write ratio is quite high. That means people will be reading more posts than creating new pages. Correct. For a read-heavy workload, our architect made a choice to use Redis or CDN caching. Okay, because we have to implement some sort of caching, and for that, our architect made a choice that okay, since it's a read-heavy workload, we will implement a Redis or CDN based caching mechanism. Okay. Then the record size per paste is quite small, around 1 to 2 KB. So this can be stored directly in a database and no further or a new object storage is required for us. So that is a big design choice again that it helped us to make. And the fourth question that we asked was we also realized that let me show that 80% of the traffic may go for top 1% pastes. Okay, so that means that of course we have to implement a caching mechanism at the backend as well. That's why we are applying something called cache first read flow, which we will look at it what it is. So now understand that at backend we are applying a caching mechanism to store the top 1% pastes in the cache. Okay, and finally the one more non-functional requirement was paste should expire automatically. Okay. Now this is quite interesting, and as automatic expiration of a paste means we will have to run a background job to automatically delete all those pastes whose expiration time has crossed, or we will have a TTL cleanup logic implemented. Okay, so this also helps us make a very important design decision that okay, we need some sort of a background asynchronous job that will automatically delete uh, the expired pastes. Correct. So we are done with level 2 or the layer 2, and we move to layer 3 where we discuss about the edge cases and constraints. So for this at layer 3, our architect has asked few very smart questions. He has asked that what is the max size of a paste? Should expired paste be auto deleted or not? Do we need attachment support? and what do we do when we are spammed or abused. Correct. So let's see what these questions correspond to. What kind of design choices? So first one is the max page size is 1 MB. Okay. So if we are to enforce such a logic, we have to have a size validation in our API or at the DB layer. So of course, we have a NoSQL database, we have a REST API supporting CRUD operations, and we can easily implement that. Next is we don't need to support any images or any binary supported. So we will have a text only schema in our database, and we would not need any media storage like S3 or like object storage, cloud-based object storage like that. So we'll keep our system simple, and we'll not need any object storage. We'll go only for a text only schema. Next, to support abuse detection, what our architect suggests is we can use a queue for asynchronous moderation jobs. Okay, so what this will do is once a paste is pasted on our paste bin, uh, we will have a moderation job that will run at the background, and that will verify the content of the paste, and it will help us to ensure that it is not an abusive post, or it is not something that is legally not correct. So this hints us that okay, we will queue these pastes one by one, and one by one we'll run the moderation jobs on these pastes, and for that we will use something very simple queuing services like AWS SQS, and we'll use async moderation jobs. Okay, that will run parallelly, and that will just verify or validate our paste for uh, abuse detection and stuff like that. That is the third thing. And the fourth thing is PII concern or legal constraints. Let's say someone is pasting their PII data. Okay, so for that we'll have to add audit logging, and we'll have to log every action or every information that every paste shares. Okay, so for that we have to implement something like AWS CloudFront or cloud logging, stuff like that, to add audit logging to our APIs. Okay, so this will help us in serving this PII concern or legal constraint functionality. So we completed layer 3, sorry, and next we move to the layer 4 or the product flows, UX or product flows. So for the UX or product flows, let us see what questions were asked. We asked that whether the paste creation should be instant or not, and we also asked whether we should show the paste URL right away, and do we support retries or undo. Correct. So these UX insights help shape the flow and the user experience, and these are very very important. So let's see what this question corresponds to. So as the paste creation should be instant, so we from this we get to know that our API, our REST API, should be synchronous and should be very fast. Got it. Next, what is the next question that we asked? Let's see. So okay, do we show the paste URL right away? So this corresponds to two things. For showing the paste URL right away, let's say the user is accessing an existing paste. Okay, then as we have implemented a cache, so the paste should hit our cache. So the hit rate on the cache should be high, which is needed on the access of a post. And the user should not wait for the paste expiry logic to run. Okay, let's say I paste some content in our paste bin, and I should not see a loading screen that tells that okay, validating content or something like that. So for achieving these two things, for achieving a high cache hit rate, we are already using the CDN or Redis cache, okay, for all our GET requests. So that is taken care of. For second one, the user shouldn't wait. What we have to do is run the expiry jobs asynchronously without blocking the main user flow. So as soon as we update or paste the content on the paste bin, we should show the user a success message, and the expiry jobs to calculate the expiration time of this current post should run at the background. Okay. The fourth point is retry possible on client network issues. Let's say uh, I am using the Pastebin app or website on a mobile phone, and the internet is not working somehow, and I'm trying to create a paste, but I'm not seeing any response, or due to network issues, the paste is not happening. So even if I try 2, 3, 4, 5 times, we should have we should not create the same paste again and again. Okay. So this hints us that we have to implement idempotency in our REST API or post route. Idempotency means even if we hit the same slash post, let's say uh, we have sorry, let's say we have a slash paste request, and we send a paste with ID 1, and let's say the content is ABC. Okay. So this ID 1 and content ABC should not be created 4, 5 times if we retry the same request body again and again. Okay. So that is what we mean by idempotency. So this is how the layer 4 is done, and asking the right questions at layer 4 or the UX product flow helped us make very important decisions, like using asynchronous tasks like expiry to avoid blocking user. Okay. And show the paste URL instantly, prioritizes the right path latency. Okay. And using the Redis CDN to serve top pastes very fast, and finally adding idempotency to protect from duplicate pastes on retries. Okay. So this was a very important video, and we saw the four-layered thinking model that we should have. Let's do a quick recap on the same. So for breaking down requirements, what we saw was we are using a four-layered thinking model. At the first layer, we think about the functional requirements of the system. Okay, what the system can do. At the second layer, we think about the non-functional requirements, or what is the shape of the system, what scale, what speed, and what kind of reliability, availability is required. Okay. After these two core foundational blocks are built, we move on to thinking about the edge cases and constraints. We ask the right questions about what edge cases can arise in our system architecture, and that can help us uncover system constraints. Okay. Finally, and the most important thing is thinking about the human touch on the system, thinking about the UX and product flows, how the end user interacts, and how we can make using the system a very good experience for the end user. Correct. So that was it about this video, and I hope this would add value to your system design knowledge. And senior engineers ask more questions than they answer, because great architecture starts with a very crystal and clear understanding, right? Design challenges aren't just about the right architecture, they're about how you how you approach a challenge or a situation with ambiguity, taking the proper trade-offs, and making good design choices, right? So that was it about this video. Thanks a lot for watching, and please continue watching this series to get a very good knowledge on this topic. So thank you, and see you in the next